Good afternoon, everyone. So, today we are going to discuss the Venturi meter. It's one of the flow measuring device. So, a Venturi meter is a fluid flow measuring device that is being installed in a pipe in order to determine or estimate the flow passing through the device. So it is usually installed in a pipe or along the pipe. So this is our pipe. So this is our pipe. So this is where we install our Venturi meter. So Venturi meter has or it's a device. It's like a two funnel that is connected with each other. So it has what we call a mouth, where if the fluid is going to that direction, so this is what we call the mouth. This right here is the mouth, then right here is the throat. So fluid will pass through that direction, so that's Q, so it will pass through that direction. Okay, so uh, assuming this is Q1, then this is Q2. So based on the continuity equation, if the fluid will pass through, let's say here is, let's say, point 1, let's say it's point 2. So if there are no leaks between point 1 and 2, so based on the continuity equation, we can say that Q1 is just equal to Q2, or you can write it this way: that's area 1 times the average velocity at point 1, and that is equal to the cross-sectional area at point 2 times the average velocity at point 2. Okay, so uh, based on this discussion, we'll just assume that the this pipe or this Venturi meter is horizontal. So it's horizontal, so that we can say that Z1, or the elevation at point 1, is just equal to Z2, or the elevation at point 2. Okay, so how does the device measure the flow passing through it? Okay, so it has the ability to measure the flow of the fluid passing through the device by um, determining the difference in pressure between point 1 and 2. So as we know, based on this equation, we know that area is inversely proportional to the velocity, right? Let's use black. We know that area is inversely proportional to velocity. We also know from our previous discussion that the velocity is inversely proportional to pressure. So the higher the velocity, the lesser the pressure. The higher the pressure, the lesser the velocity. Okay, so by determining the difference in pressure, we can determine the velocity of the flow passing through the instrument. Okay, so in determining the difference in pressure, that is where the manometer comes in. I think we not really discussed in detail based on our previous discussion. We have encountered manometer in several examples. Well, we have different types of manometer. We have an open manometer, we have differential manometer, we have U, like U type, U shape type tube manometer. So we cannot really determine the pressure at different points of connection in the manometer, but we can determine its difference. Okay, so balik ko na ko, we cannot determine the the value of the pressure, but we can determine its difference. But if it's an open type manometer, it's a what we call a piezometer. A piezometer is an open type manometer. Since it is open, most likely open, the open part is exposed to atmospheric pressure. So in that way, we can determine the approximate value of the pressure at a certain point in your manometer. Okay, so this is where the manometer comes in. But before uh, before going to that, we will first establish the equation that can be used to determine the velocity of the flow. So as you can see, this is point 1, this is point 2. So basically point 1 is just, or the diameter of the point 1 is just, basically it's equal to the diameter of the pipe, since it is the what we call the mouth. So we have here, of course, I'll change the color para ma-emphasize. Klaro na bang yellow? um, so okay, so this is the diameter D1, and here this is the diameter D2. We can actually measure that one. If we have a device, we can accurately measure the value, or that the diameter. Okay, so if we uh, establish, or if we cast the Bernoulli's energy equation between point 1 and point 2, so first, assuming that there's no loss, there's no head loss, we'll just put the head loss later in order to not to complicate the equation. So casting the Bernoulli's energy equation between point 1 and point 2, so this is the Bernoulli's energy equation. So the total energy at point 1 is equal to the total energy at point 2. So the total energy at point 1 is the energy due to pressure, or in our case, we can write it as pressure head, then plus the velocity head, and plus the elevation head. So assuming there's no losses between point 1 and point 2, we can simply say E1 is equal to E2. So we can also write the total energy, or the sum of the total energy at point 2. Okay, so Bernoulli, velocity head at point 2, and elevation head at point 2. Okay, so we can only cancel out the elevation since they are equal, since the pipe is horizontal. So we can cancel out Z1 and Z2. So what if the pipe is not horizontal, if it's inclined or vertical? So I will explain in another video how to, or what would be the equation if the pipe is not horizontal, it's inclined uh, or vertical. So this time it's horizontal, so you can cancel out the Z1 and Z2. So what remains is the equation is only a function of velocity and pressure. Okay, so we can rearrange the equation in such a way that it would be, oops, P1 minus P2 over gamma, that is equal to V2 square minus square over 2G. Okay, so we have uh, one equation and two unknowns, or in this case we have four unknowns: P1, P2, B2 and B1. But actually P1 and P2 we don't need to, for P1 and P2 we don't need to really determine the value of P1 and P2. We just need to get the pressure difference. So P1 and P2. Okay, so on the right side we have V1 and V2. So we need to have another equation in order to express V1 in terms of V2 or V2 in terms of V1. So we have this equation, the continuity equation. So we can express V1 in terms of V2 or V2 in terms of V1 by determining uh, the proportion of area. Okay, so uh, actually we can express V2 in terms of V1. So V2 is equal to A1 minus itong tarongan. We have A1 over A2 times V1, right? Okay. We know that A1 is equal to that, diba that's area of a circle. So we will presume that the pipes are all circle. Okay, so pi d squared, that's the area of the circle. So pi d1 squared over 4 over area of A2. So pi over 4. So that is the A1 over A2, right? But we can always cancel the pi. Actually pi and 4. So what remains is d1, that's actually d1 squared over d2 squared. Now since variables they're not variables considering particular uh, particular instrument. Let's say for a particular venturimeter, D1 and D2, they are constant, right? So if they're constant, we can just simply replace it with, let's say, N. So N is D1 over D2 squared. I'll just rewrite it ha. Ako lang balik ko ng suwat para di mo malipat. Okay, most likely, based on experience, based on personal experience, and based on experience of my students before, malipat sila. Most likely, dili sila di sila maka-square. D1 square, D2 square. Because, as I said nga, makalimot og square. Because, since V1 or V1 and V2 here, they are square, di ba? So, might as well ato sa ni siyang square, right? So mahitabo ani, I'll just use the red one para ma-emphasize. V2 square. So we already replaced A1, we already replaced this one with N, di ba? So what will happen here is it will become N squared and V1 squared, right? So in that way, we can now express V2 in terms of V1. I will use another color. So what will happen in our equation is it will become P1 minus P2 over gamma, that is equal to V2 will replace V2 by N squared V1 squared minus V1 squared, right, over 2G. So we can factor out V1 because we need to express everything in terms of V1 because this is what we want to solve, the velocity at point 1. So the equation will become at 1 and we'll factor out V1. That would be 1, now N squared minus 1 over 2G. So if we want to solve for the velocity at point 1, V1, so we can just rearrange the equation. That would be P1 minus P2 gamma. Remember, P1 minus P2, we can also express it in terms of delta P. Okay. Times or multiplied by 2G over N squared over 1. Then the entire thing, since V1 is square, so we can square root the entire thing. So that will be the velocity or the equation in order to solve for the velocity of V1. Okay? Okay, so for the derivation of Venturimeter installed in a pipe where the pipe is not horizontal, it can be inclined or vertical. So I will just show it in another video. But right now, this equation is the velocity or the equation of the velocity of venturimeter if the pipe is horizontal. I'll just put it here para di malipat. Okay, so again I will explain it in the next video. Okay, so thank you for your attention.